tried for 128 and minus 128. And we realized that minus 128 can be included, and 128 plus 128 can't be included. Okay, it should be represented by some other representation, and maybe we need more number of bits. So this is what we have discussed in the previous class. That's why we have included 128 minus 128 and not plus 128. To represent plus 128, we need more than 8 bits.
Okay, ma'am. Yeah, ma'am.
So any student in this batch who is taking computer programming class for the first time today? Any student in this batch? Okay. So how many students who have missed some classes, maybe due to their late admission, uh, or maybe some other reasons, they have not attended all classes and maybe they have started after 1 week? Are there any students, such students who have joined a little late?
Yes, ma'am.
Can you please type hi in the chat box? Those, yeah, something. Those who have joined late. Just one student. Are there other students as well who have joined a little late? Okay, so we'll see if we have sufficient number of students. I will take an extra class for the previous, related to previous lectures which we have already taught. If there are few number of students, then we will take an extra class so that we can come in sync with other batches. We are moving a little behind. Okay, so let's start with today's class. In previous class, we have started with number system representation. We have seen how to convert decimal number system to binary number system and vice versa. We have already discussed how to obtain the range for signed integers and unsigned integers. Now, the question is, we have seen how to convert unsigned integers, unsigned binary representation into decimal. But suppose we have 2's complement and 2's complement representation for a number. It can be positive, it can be negative. Then how can we convert this number into decimal? So So how can we convert 2's complement representation into decimal representation? Now in 2's complement representation, we have seen that the most significant bit is a sign bit. And if it is 1, it means it's a negative number. Otherwise, it's a positive number. So first we see if the integer is negative, we complement it to get a positive number. What do we mean by complement? It's a 2's complement. Okay. Then convert this integer to decimal as usual. And if the integer was originally a negative number, put a negative in front of the decimal representation. Put negative sign if number was originally a negative number. So let's instead of 8-bit 2's complement number, suppose I am taking 4-bit 2's complement representation. So in 4-bit 2's complement, suppose I represent a number like this. Okay. I want its equivalent decimal number. The first step is we need to check whether this is a negative number or a positive number. So it's a negative number or a positive number?
Negative.
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 Yes. Because here
Because
the most significant bit is 1. Okay. So what we will do, we will take its 2's complement. To take 2's complement, what I will do, I first take 1's complement, that is I invert these numbers and then I will add 1 to it. So it will become 0. So this is my first step. Now I will convert this number into its decimal equivalent as usual. So what is this number? This is 4, 6, 7. Okay. The third step is put negative sign if number was originally a negative number. So this was a negative number because sign bit was on. So I'll put negative sign in front of it. Is this clear?
yes,
No.
yes.
So quickly, everyone has to do it. And please don't write your answer in the chat box. I will ask the output separately. So this is my binary number and I want its decimal equivalent. This is 8-bit 2's complement. Okay. Vithal Sanadhya. Done?
No, ma'am. 1 minute.
Okay. Vedang, done?
Yes.
Okay. So, Vithal, when you are done, please tell us the answer.
Minus 64.
It is 64. So, let me write it. Vedang, your output?
96.
Okay. Vinita, your output? Vinita, can you hear me? Vinita, you're not audible. Can you please write your answer in the chat box? Please write your answer in the chat box. If you are not able to do, please write not done. Vinita, I want decimal representation. Is this a decimal representation of the binary number? So what is the decimal representation? And I'm not able to pronounce your name properly. It's Vemu Lathushar Reddy. How do you pronounce your name? So minus 98. Tushar. Okay, good. Tushar. Am I correct, Tushar? Pronunciation is okay? Okay. Now Yash Hisaria. Yash Jain. Minus 97.
My minus 97.
Okay. I have two students for this answer. Yashasvi Garg.
Yes, ma'am. Minus 97.
Okay. Vardhan Sharma.
Ma'am, minus 97.
Utkarsh Gandhi.
Minus 97.
Utkal Sharma.
Minus 97.
Vedang is changing his output from 96 to minus 97. So now Vedang, you explain why. If you can unmute your mic, please do that. Yeah, Vedang, how is this 97 minus 97 coming?
Hello, am I audible?
Yes, you are audible.
Okay. So, ma'am, for that,
This
two,
was my number.
yeah.
No.
So, ma'am, we'll start from 0, 1, 2, 3. That's the index now, right? 2 raised to 0, then 2 raised to 1. That's how we go.
ऐसा
Yeah.
तो माइनस ये कैसे आ गया माइनस 97 कैसे आ गया
Ma'am, these are the index number, then we have to change them. Uh, 0 1 1 0 0 0 like that.
क्यों करेंगे change हम?
Pardon?
Why we need to change 0 1 1 0? Why we need to invert these bits?
Negative, because of negative number.
How you see? How you can say that it is a negative number?
I forgot that.
So then, how you got this minus 97? Because you
No,
find get the reverse
last
engineering.
for negative number we have to change that. So
But when you don't know why it is a negative number, then how you can say that it's a minus 97? You did reverse engineering because majority was saying minus 97, so you thought, okay, just reverse engineering it.
and the last example you did that
हाँ,
change
the
0 to
meaning
1
हो
and
गया.
2 to 0. So I
मैंने
did
पूछा,
same like that.
how you say that this is a negative number? Okay. So, okay, just turn off your microphone. Utkarsh Gandhi. So now can you unmute your mic? Is it possible?
Yes, ma'am.
So now explain how you got this minus 97.
मैम सबसे पहले नेगेटिव नंबर है फर्स्ट में स्टार्टिंग में 1 इसलिए
ये ये 1 है इसलिए
ने, ने
या ये 1 है?
स्टार्टिंग फर्स्ट नंबर पे
So starting from left or right?
लेफ्ट
इसको लीस्ट सिग्निफिकेंट बिट बोलते हैं या मोस्ट सिग्निफिकेंट बिट बोलते हैं?
इसको मोस्ट
क्यों? Why it is called as most significant bit? Because it has high maximum weight. Okay, चलो बताओ अब आगे. So it's a negative number.
फिर आगे
Then you will invert
यस
it.
मैम फिर बात यस मैम तो फिर 0 1 1 0 0 0 0 0 फिर इसमें टूज निकालने के लिए 1 ऐड कर देते हैं तो उसके बाद में 0 1 1 0 0 0 0 1 उसके बाद में फर्स्ट वाले को 2 की पावर 0 इंटू 1 कर देंगे. अच्छा इधर से हाँ और उसके बाद में सेकंड वाला 0 0 0 है ही बाद में फिर 1 1 जो आएगा उसके अंदर एक बार 2 की पावर 5 एक बार 2 की पावर 6 तो माइनस 97 इससे आंसर आ जाता है.
So 97 आ गया and since it was a negative number, I've put a negative.
Minus.
Is it clear to everyone, those who have said 64, 96 and minus 98? Is it clear? Or you want to stick to your answer? And other students as well, is it clear to everyone?
Excuse me, ma'am.
Yes.
In the last class, we took an example where this binary digit code was 101001, and it was decimally represented as the number 41
Huh.
with the
So
positive sign. So
so this is what we have discussed in previous class, no? Ki there will be certain numbers which we can specify that these will only have positive sign. We are only considered positive integers. So if we have positive integers, suppose we are dealing with 8 bits. We have 8 bits for integer representation. Now, if we specify that yes, we are dealing with only positive numbers, then we don't need 2's complement as such, and all 8 bits will be used for representing numbers. When we talk about negative integers, or we can say signed integers as well, which we can have positive integers and negative integers both, then one bit, the most significant bit, is considered as sign bit, and remaining 7 bits will be used for representing your number. Okay, that's why. हाँ, तो जो हमने लास्ट क्लास में करा था, पहले हमने सिंपल रिप्रेजेंटेशन सीखा था. वी वर ओनली कंसीडरिंग पॉजिटिव इंटीजर्स. सो ऑल बिट्स वर यूज्ड फॉर रिप्रेजेंटेशन ऑफ नंबर. उसकी रेंज भी अलग थी, इफ यू रिमेम्बर. इट्स रेंज वाज
उसकी रेंज भी है
0 to
0 to 2n minus 1
और अगर हम
2
टूज
raised to the power n
की बात करते हैं तो इट
तो
हैज रेंज.
2 to the power 2 raised to the power n to 2 to
Minus
the power
1.
n minus 1.
Yes, okay. So
So
under
like this means that whatever like the answer which we need to calculate will depend upon the question which is being asked. Like
yes,
it needs to be this needs to be specified in the question that whether we need to consider it as a sign bit or not. Is
yeah.
it?
If there can be two type of question that we are only considering positive integer. This is a binary representation of unsigned integer. So when we talk
Oh,
about unsigned integer, we are considering only positive integers. And if the question says that this is a 2's complement representation, or it's a binary representation of a signed integer, then it is understood when means both are same, 2's complement or signed integer representation. Is it clear?
yes, ma'am. Thank you.
Ma'am, if we have to do 2's complement and the number is already positive, then we can do directly by raising
Uh-huh.
2 ki power and then adding it.
Yes, it is as usual.
Okay, ma'am. Thank you, ma'am.
So till now we have discussed about signed integers, unsigned integers, and signed integers. Now let's talk about fractional number representation. When we talk about fractional representation, fractional number representation, we have two types of representation. Fixed point number and the floating point number. Generally, we use floating point numbers only, and in floating point numbers also there is a standard. We will talk about it later. Let's first talk about fixed point number representation. So what do we mean by fixed point number representation? It's a real number having a fixed number of digits after the radix point. So suppose this is my number which has integer part, then there is a decimal which is also called as a radix point, and it has fractional part. So this is integer part and we have fractional part. Okay, and this is my radix point. These are m bits and these are f bits, fractional number of fractional bits. And t is equals to m plus f represent total number of bits. This is an unsigned number. Unsigned fixed point number. We can have a signed bit as well. So one bit will be the most significant bit will be used for representation of sign. It is same if the sign bit is 1, it's a negative number, else it is a positive number. So here as well, it's M, F. So here total number of bits are M plus F plus 1. Okay, this is my signed floating point number. Now suppose, for example, M equals to 3 bits and I am using 4 bits for representing the fractional part. And total number of bits are 7. Okay. And this is the binary number which is given to you. So M bit is total number of bits used for integer, representing integer part. So here comes the radix point and 4 digits, remaining 4 digits will represent negative or fractional part. Okay. Here the power will be 0, 1, 2, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. For fractional part, it is minus 1, minus 2, minus 3 and so on. Okay. So this number is, the decimal equivalent of this number is, this is 0 into 2 raised to power 0 plus 1 into 2 raised to power 1 plus 0 into 2 raised to power 2. And similarly, it is 1 into 2 raised to power minus 1 plus 1 into 2 raised to power minus 2 and remaining are 0. So this can be written as 2 plus 1 by 2 plus 1 by 4. Is this clear? Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So you
Yeah,
will be
ma'am.
given a binary number, binary representation, and it will be given in the question like how many bits will be used for representing a fractional part and how many bits will be used for representing integer part. And if it's if it's an integer number, then if it's a signed number, you have to see total number of bits, and accordingly you have to see whether sign bit is on or off. So it can be, suppose this is my number and total bits are 8. Okay, so these 3 bits will be used for integer part, these 4 will be used for fractional part, and 1 bit is your sign bit. Okay, so you have to see, after all this conversion, you have to see whether this sign bit is on or off. This, since sign bit is 1, so it is a negative number. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Can you repeat the last point? If the first number is 1,
Yeah,
this must be given fixed point or fractional
in the
point.
question it is given, it will be given whether how many bits will be used for representing integer part, how many bits will be used for representing fractional part, and t gives you total number of bits. Suppose this is the number, this is the number I have. Since total number of bits are 8 and 3 bits for integer part and 4 bits for fractional part, so the 1 bit will be considered as your sign bit, the most significant bit.
Ma'am, this is also fixed point number, or is it now floating point number?
We are talking about fixed point number only. That's why number of bits are given to you. कि कितने bits are used for integer and कितने bits are used for fractional part.
Okay.
I'm here m equal to 3 or 4.
M equals to 3. Only we are using 3. Everything is same. This is same.
Are we supposed to do one's complement also if the number is negative?
No, here we don't need.
Okay.
Ma'am, please can you scroll a bit up?
Here you just need to check whether it's a signed bit or unsigned bit.
Ma'am, is the signed bit is a part of floating point number?
Abhi, we are not considering floating point number. These both are representation of fixed point number.
Okay, thank you.
So is this clear so far? The fixed point representation. Now let's move to floating point representation. First, we will be talking about general floating point numbers, and then the certain standards which has been created for representing floating point numbers. Okay. So let's talk about floating point numbers in general. So this fixed and floating is with reference to the whether this radix point, whether this decimal point can float or not. If the number of digits are fixed, then it's a fixed point number representation, and if we can move it due to a trade-off between range and precision, it is called as floating point number. So how we can represent a floating point number? So it's a significand into base exponent part. Significand is also called as mantissa. So for example, this is my number. So here, what does this mean? It represents 1.452. And if I change the value of the exponent, the position of decimal point, sorry, the position of decimal point will change. Now this is the general formula for floating point number representation. In computers, we use base 2. Okay, in computers only base 2 can be used. Now suppose a number is given to you. So this is sign bit. This is exponent. And this is significand. This is 1 bit, number of bits 1, A and B. Total number of bits are A plus B plus 1. Now suppose this is given in the question. A is equals to 3, B equals to 4 and T equals to 8. And this is your binary number. So this 1 bit is your sign bit. 3 bits represent exponent part and 4 bits represent significant part. So this is equals to this is a positive number or a negative number?
Negative.
Negative.
ठीक है.
Negative.
और 0011. What is the decimal representation of this number?
3.
And
3.
what is the decimal representation of this number?
2.
ठीक है.
2.
So this is 2 and this is 3 in decimal representation. ठीक है. This is your general formula. Significant into base raised to power exponent. And base in computers can only use base 2. So significant is 3 into 2 raised to power minus 2. And since it's a negative number, I will put here minus 3 raised to power 2 raised to 3 into 2 raised to power minus 2, which is equals to minus 0.75.
Remember, significant is 4. Significant is 4.
कहाँ आया? There are 4 number of bits which are used to represent significant. Okay, यहाँ पे हम रेडिक्स यूज नहीं कर रहे हैं. We are representing in terms of exponent form. Okay.
How to know if the exponent is positive or negative?
Exponent is not positive and negative. Here we take only positive exponent. Number can be negative or positive.
So how I didn't understand that. How do you take minus 2 raised to power minus 2 instead of 2?
अच्छा. This is minus exponent. I forgot to write it. Clear? This is according to the formula. This is minus exponent. Is it clear?
ओके मैम अगर एक्सपोनेंट का नंबर जैसे अभी तो 2 आया था, अगर -2 आता तो हम फिर -2 तो 2 हो जाता, फिर 2 raised to power 2 लिखते.
एक्सपोनेंट कैसे?
मैम जैसे अभी एक्सपोनेंट की वैल्यू 2 आई है इस क्वेश्चन के हिसाब से. अगर किसी और क्वेश्चन में वैल्यू -2 हो,
-2 होगी नहीं ना. -2 कैसे होगी एक्सपोनेंट की वैल्यू? सॉरी +2 मतलब डेसिमल रिप्रेजेंटेशन होगा ही नहीं ना. वी आर नॉट कंसीडरिंग. हमने यहाँ पे ऑलरेडी साइन बिट दे दिया है. नाउ वी आर ओनली कंसीडरिंग हाउ मेनी बिट्स आर यूज फॉर रिप्रेजेंटिंग एक्सपोनेंट पार्ट एंड द सिग्निफिकेंट पार्ट. सो यहाँ पे बस हमारे पास यही डिजिट्स हैं. इनको हम सिंपल कैटेगराइजेशन करेंगे. वी आर नॉट अप्लाइंग 2's कॉम्प्लीमेंट हियर. Okay, we have already taken this as a sign bit. Now all 4 bits will be used for representing your decimal. Will be used to represent decimal number. Okay. अच्छा.
एक्सक्यूज मी मैम,
क्या?
वो एक्सपोनेंट की वैल्यू 2 कैसे आई? हाँ 2 कैसे आई?
चलो इक्वेशन में दूसरा करते हैं हम. ठीक है. Let's take another example.
Okay.
Here a equals to 3, b equals to 4 and t equals to 8. T equals to 8. So this one bit is the sign bit. 3 bits will be used to represent exponent. and 4 bits are used for representing significant. So, and what is the formula? Significant into base raised to power minus exponent. Significant, अच्छा चलो अब 0101. What is the decimal equivalent of this number?
5.
5.
And what is the decimal equivalent of this number?
3.
3.
3.
3. So हमारा represent इस formula के according how to write it?
5 into 2 की power minus 3.
5 into 2 raised to power minus 3. Because base will remain 2. Is this clear? According to this formula? Is it clear
Yes,
to
ma'am.
Yes, ma'am. Yes, ma'am.
अब ये 2 raised
Yes,
to
ma'am.
power minus 3 को मैं कैसे लिख सकती हूँ? Can I write it like this?
Yes, ma'am.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Is it a positive
Yes,
number
ma'am.
or a negative number? Do I need to add negative minus sign?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So this is all about number system representation in general. This is the floating point number system representation in general. Okay. Now to maintain certain standards like how many bits should be used for representing Mantissa part, how many bits should be used for significant part. So an IIT standard, IEEE standard, IEEE 754. This standard has divided this floating point representation into as single precision and double precision. So this is single precision IEEE 754 floating point standard. According to this standard, the total number of bits used to represent a floating point is 32. So 32 bits will be used to represent a floating point number. And out of that is t is equals to 32. And out of these 32 bits, 8 bits will be used to represent your Mantissa part or significant. That is B. And this, significant will be represented by 23 bits. And exponent part, that is A, will need 8 bits. And 1 bit will be used for representing your, will act as your sign bit. So this is 1. There is another standard, another IEEE standard, which is called as double precision. Double precision IEEE 754 floating point standard. It uses 64 bits, total 64 bits. Out of these 64 bits, 1 bit will be used to represent sign. 11 bits will be used to represent exponent, and 52 bits will be used to represent your significand. So for example purpose, we can't take these these large number binary representations. So this is in general representation of a floating point number. Now if any number is given in single precision or double precision, this is the standard, and you can find the decimal equivalent uh, accordingly. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So
Yes,
it is
ma'am.
all about your basics, and the basics which will be requiring to which are required to understand concepts of C properly. Now from next class we will start with C. Okay, so before that I want you to please refresh all the basics of Python as well, because few things are common and few things are different. So if you have understood Python properly, it will be very easy to understand these concepts in C. There are few differences. We will be discuss those differences while discussing these similar concepts in C. Okay, is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
And I may take an extra class this Saturday, so please plan your weekend accordingly. There may be an extra class of 1.5 hour, uh, means before lunch. So plan your
Okay.
weekend accordingly. Okay.
Okay. Ma'am, one doubt.
Yes.
Ma'am, the in fixed number, fixed point number, we did an